All right, guys, we're doing lesson 7.2. Please have your fraction bars out. You're going to need 2 trays of them to work together for this one today. Multiplication, fractions, and whole numbers. Your essential question: how can we use a model to show the product of a fraction and a whole number? Here we go. Martin is planting a vegetable garden. Each row is 2 meters long. He wants to plant carrots along 3/4 of each row. How many meters of each row will he plant with the carrots? So I see 3/4 of each row. So I know I'm going to multiply 3/4 of each row. What's each row? 2 meters. So 3/4 times 2. So we are going to start, and we always lay out, even though this problem needs it, we always lay out the one fraction bar as our base, our benchmark number, because that gives us a benchmark to go from greater or less than to see if our answer is correct. But for this problem, we need 2 of them. So please lay out 2 of them because we have 2 meters. And you're not going to be able to see all of mine, but I'm just going to. All right. Place 2, okay, to represent the denominator of each fraction 3/4, find 4 fraction strips, all the same denominator, that will fit exactly under the 2 hole. So now here's your experimental time of laying out halves. Well, I know halves will work because I know 2 halves will be there. So I'm going to go with halves, and I'm just going to put them out there. So if we were drawing this, and this is your model, so I put halves out. Okay, that one doesn't work. So I'm going to draw them, what I have written, or what I put out. I'm going to put 1/2 in each one of these. All right, circle 2/3 or 3/4 of 2 on the model that you drew. So I'm going to circle those that I drew, and if you look, how could I draw 3 of those? Well, it would be 1 whole one and 1/2 of the other one. So complete the number sets. 3/4 times 2 equals 1 whole and 1/2. So the meter of carrots is 1 whole row and 1/2. Now, does that make sense to you? Well, now let's kind of look at this as a multiplication problem. So 3/4 times 2. And if I look at this, I get 6/4 when I multiply straight across. Why did I put a 1 over the 2? Because that's how I make a whole number a fraction. Well, I know this is an improper fraction, so I can make it a mixed number. How many times does 4 go into 6? Goes into it 1 time. I put my -4 because that's what 4 over 4 is. And I have 2/4 left over. I know that this is not simplified yet, so I can divide them both by 2, and I get 1/2. It's 1 and 1/2. Explain why you placed 4 fraction strips with the same denominator under the 2 whole ones. Well, because how far was it? What did I have to start with? I had to start with 2, so I had to find out what equally went into that 2 meters. So explain how you would model 3/10 of 2. Well, then I have to go back, and I would still do 3 parts out of the 10. So that means I would have to cut this part into 10 extra strips, equal parts. So how much would that be here? So I need to have 10 of those. So if I broke this into what is 10, I have to put 10 all the way through here. As you can see, I got 4 halves, so I would need, what would I need for 10 to get all the way across? Well, I think it would be 1/10, because why? Because it's going to take 10 of these to cover that. Or I could do fifths, 1/5. And if I circled 3 of those, that would be 3/5. So let's see what we get when we multiply it straight across. 3/10 times 2, I want to make that a fraction, so it's 2 over 1. I get 6/10. That's not simplified. I can simplify it, divide them both by 2, and I get 3/5. And that's how many fifths would be, how many would it be? 3 of them. All right. Let's move on. So let's do the steps now. It says, in the investigation, actually, you multiply the whole number by the fraction. You can also show a model to multiply a fraction by a whole number. So before we had a whole number times a fraction, but does it matter when we're multiplying? We know multiplying is a commutative property, so does it matter? Is my answer any different? Well, let's check. So step 1. Oh, we better read the story problem. Megan was helping clean up after a class party. There were 3 boxes remaining with pizza in them. Each box had 3/8 of the pizza left. How much pizza was left in all? All right, so we need to, so I know I'm multiplying because there was 3/8 of the pizza. Well, how many pizza boxes were there? There were 3. So right here, I'm going to draw 3 pizzas. I know I'm going to break them into 8s because that's my denominator. So I broke it into 8s. How many in each one was? So I'm going to color in 3 of each one was. So now I have 3/8, 3/8, and 3/8 of each one of those were full. So if I put them all together, well, I could do it by my drawings. I could take these 3, put here. I could take these 3, put 2 there and 1 here. So I know that each circle, okay, each circle shows 3/8 of the whole. 3 circles show how many 8s? Well, 3, 6, 9, 9/8. 9/8 is a improper fraction. 8 goes into 9 one time. Minus my 8 off of there, I have 1/8. With my diagram here, with my model, what did I have? I had 1 whole piece with 1/8 left over. Now, if I was going to multiply that, we can look at step 3 on how they're multiplying it. They did 3/8 plus 3/8 plus 3/8, and that is 9/8. If I'm going to multiply it, I'm going to 3 times 3 is 9. 1 times 8 is 8. So 9/8 or 1 and 1/8. So if you need to draw, you can. If you're starting to understand how to multiply fractions just by moving, lining up your fraction, making your whole number a fraction by putting 1 over top of it, then do it that way. All right. Here, they draw a model for you to do. They've got it here. I would like you to answer the question. I want you to do 1, 2, 3, 4, and 5. Find the product. If you need to draw a model, awesome. If you don't, show me your work, what you're doing. Think smarter. Let's do this one, and just as a partner, let's do it and see how, if we can think smarter than harder. Give that your best shot. We'll come back and do this one. This one's a good challenge one. All right, and we are doing the evens here, and 1 or 2, and all of the rest.